Hi everybody. So in this video we're going to be actually going to be a rather short lesson on the area of a triangle, which I know that you've seen before and we probably think we know everything there is to know about it. You've learned in other math classes most likely that the area of a triangle is 1/2 base times height, or 1/2 base times the altitude. And that's of course correct, and we're going to just go over it. We're also going to see there are some other versions of this formula. This is a great formula to use if you know what the base is and you know what the height is. But then there are some other things that come up where things aren't always that simple. So the reason why, of course, this is true is because when the triangle is like this, we can draw a box around this so that we can see that the whole triangle can be contained in this rectangle. And also because this area and this area is the same, and this area and this area is the same, the area of this triangle is exactly half the area of this rectangle, and the area of the rectangle is base times height. Okay, so the area of the triangle is half of that. And even if the triangle isn't as nice as this, and we get something like this, we can basically always take this and put it on this flat side, this biggest side, so we'll get something like this. Okay, so this formula is always valid. Now, let's say we don't know, we're not given the height, but we are given two sides of the triangle, and we're also given the angle that is between them. Well, that's great because we can easily find what the height of the triangle is, because we can draw the height here, and we get a right triangle here within our big triangle, and the sine is going to be h divided by b. The sine is going to be the sine of theta will be h divided by a. We can multiply both sides by a, and we'll get h is a times the sine of theta. Okay, and then just substitute that in here for h, rearrange the a and the b, and we get 1/2 ab sine theta. So that's the formula, another formula for the area of a triangle. And when you take calculus, you'll see you'll be doing a few homework problems where you try and beat this. All right. In fact, I think you might have seen this before in Math 128, and they just give you the formula and they ask you to take your word for it. Okay. So there's not much to do here. Like in this first example, it's just a case where we have the angle is 6. This side is the angle is 32 degrees. This side is length 6. This side is length 8. So the area would be 1/2 6 times 8 times the sine of 32 degrees, okay, which is 12.72. Okay. Okay, I'm just going to double check this because I'm a little disorganized today, and yes, that's right. Okay. All right. So that's great. Now, what happens if you're not given the angle? Okay, this is a case where you have side, angle, side. What happens if you're just given all three sides? Well, this isn't that big a deal because we know from the previous section with the law of cosines we can find the angle of all three angles from just using the law of cosines. Okay, so let's say if we wanted to find this angle here, we call that theta, and we wanted to find the well, obviously then the area would be 1/2 times 7 times 9 times the sine of theta. What's the sine of theta? Well, let's first find what theta is, and to do that we first find what the cosine of theta is. And from the law of cosines, okay, we get that this side is opposite theta, so 4 squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of theta. All right. So we can subtract 7 squared and 9 squared from both sides. Okay. And then we can divide by -2 times 7 times 9. Okay, and then this cancels out with this. And so the cosine of theta is going to be point on your calculator 0.90476. Okay, it's always good to take as many digits as you can when you're using a calculator. So theta is going to be the inverse cosine of this. Okay, which is approximately 25.2 degrees. Okay. All right. So the area then is going to be 1/2 7 times 9 times the sine of 25.2 degrees. Okay. Which is, let's say, approximately 13.41. Okay. Now, notice that you don't even need to know the angle, because if we know the cosine, we could just find the sine, just because we know the sine of theta. In this case, would be or the sine squared of theta would be 1 minus cosine squared of theta, and this would be 1 minus 0.90476 squared. Okay, so we could correct and then take the square root. So we could do things that way and just plug that in. So we don't necessarily have to find the angle, but it's maybe a little easier if you do it that way, maybe. Okay. Well, there's actually one more formula for the area of a triangle, which actually kind of uses this, where you never actually find the angle, and you're just using some tricks of trigonometry. So this is Heron's formula, and we're just going to derive it together. You're not going to be asked to derive this for a test or anything. So if you want to just skip to the formula, that's fine, but at the end of the video. But I just want to show you where this formula comes from. Thankfully, we're not in class where I would spend 10 minutes writing this on a board and you copying it. But I think even if we were in face-to-face, I would give you this and we would just look at it together. So we don't spend too much time on it. Okay, so let's go to page 2. All right, so we have this idea of, here we're given a triangle with sides A, B, and C. And we need this concept of something called a semi-perimeter. So the perimeter of a triangle is just the sum of all the lengths, all three sides, or the length of the sides, and the semi-perimeter is half of that. Okay. Now you'll see why we need this concept of a semi-perimeter later on. What we're going to do is try to find this. Now this theta is not given, but we're just going to call this the angle between A and B. We'll call that theta. And then by the law of cosines, c squared is equal to a squared plus b squared minus 2ab cosine theta. And from there we can actually solve the cosine of theta. We can, just like exactly what we did in the previous example, we subtracted a squared and b squared from both sides and then divided by negative 2ab. And if we don't like the minuses, we can just multiply and divide by negative 1 and we get this. We get a squared plus b squared minus c squared divided by 2ab. Okay, and then the area is 1/2 ab sine theta. Now here's a little trick. We can write theta as 2 times theta over 2. And we have a formula for the sine of 2 times an angle. That's going to be 2 times the sine of the angle times the cosine of the angle. So here we replace sine of 2 theta over 2 with 2 sine theta over 2 cosine theta over 2. And now we just have to remember the formulas for the sine for half angles. Okay. And first we have that the sine squared of theta over 2 will be 1 minus cosine of theta over 2. It's one of the formulas that you're either memorizing or writing down a lot. We can substitute this expression for the cosine of theta. We can now get, then within this, we have 1 minus this, So we can get a common denominator. We can take this 1 and multiply and divide by 2ab. So we get 2ab minus a squared minus b squared plus c squared all over 2ab, all divided by 2. When we divide by 2, where it's the same thing as multiplying by 1/2, so this really just becomes, we can get this as a single fraction where with the denominator is 4ab. And we can rearrange some terms and get c squared minus the quantity a squared minus 2ab plus b squared in the numerator. All right, so the reason why we do this is because this, when you get really good at algebra, and even if you're not, you should recognize this is the same thing as a minus b quantity squared. Okay, so now this is going to, that's what this is. And now, oh my God, look at this. This is a difference of 2 squares, right? So your square of c minus the square of a minus b. Well, we can factor that. Okay, that's a plus a minus b times c minus a minus b. Okay, this we distribute this minus sign, so we get c plus a minus b over c plus b minus a, all over 4ab. And this is where the semi-perimeter comes in, because 2 times the semi-perimeter is going to be a plus b plus c, right? So c plus a, if we subtract b from both sides, we get 2s minus b. Okay, so then c plus a minus b is going to be 2s minus b, which is the same as 2s minus 2b. Okay, so this can be replaced with 2s minus 2b. And then similarly, c plus b is going to be 2s minus a, and so c plus b minus a is going to be 2s minus a, which is 2s minus 2a. So that's how we get this thing down here. And we can factor out the 2's, and they cancel with the 4, and we get s minus b times s minus a over 2ab. Okay, so that's half, about a little less than half the battle. Then we do a similar computation, and we get this. If we do the same thing for the cosine squared of theta, well, it's this formula we also have. The minus now becomes a plus. We can do the same substitution and do some similar, get a common denominator, do some rearrangements. In this case, we get a plus b quantity squared minus c squared over ab. This is a difference of 2 squares again. So this is a plus b minus a plus b minus c times a plus b plus c. Okay, I've rewritten this, so usually this factor would be first, but it doesn't matter. Can factor and once again we can check that the a plus b minus c is equal to 2s minus 2c, and of course a plus b plus c, that is the perimeter, so that's twice the semi-perimeter. Okay, so this 2s minus 2c, I'll leave it for you to do that. Okay, it's a similar calculation what we did before. We can factor out the 2's, they'll cancel with the 4, we get s minus c times s. And now we can put everything together, okay? Because we showed last time that the area of the triangle was AB times the sine of theta over 2 times the cosine of theta over 2. So that's going to be AB. This is the square. We take the square root. So this is the square root of the, what was this, the sine squared. Okay, so this was the sine squared. So the square root of sine squared is sine. Okay, so we get this, and then we get this. Now, after that substitution, we just get this. And in this case, we don't have to worry about, do we take the positive square root or the negative square root, because, theta we're really talking about the sine and the cosine of theta over 2. So the most that theta can be is 180. It's actually less than 180. So if you divide by 2, that's going to be less than 90. So you're going to, this theta over 2 is going to be in the first quadrant. So the sine and cosine are both positive there. So that's why we don't need any, well, we don't have to worry about plus or minus. All right, now we just bring these to get with the square root of this times the square root of this is the square root of this times this. And then this is this AB squared. We take the square root of AB squared. That's just AB, and that cancels with this AB. And so we get this square root of S minus A times S minus B times S minus C times S. And so we get Heron's formula. So Heron was a Greek mathematician. He proved this around 60, the year 60, Common Era, where the Greek mathematics was really getting started, and they wrote a lot of stuff down there, including this one. This is a square, so the area, so the area of a triangle can actually be computed just in terms. So you know all three sides. You can actually do it without finding any sines and cosines. You can just do the find the semi-perimeter. Okay, so we have so this is the formula where S is the semi-perimeter of A plus B plus C over 2. And just for good measure, if we wanted to go back and do this, use Heron's formula for our second example. So here where we had, in this case, the semi-perimeter would be 7 plus 4 plus 9 divided by 2. Well, that's 20 divided by 2, that's 10. So the area, looks like the area should be square root of 10 minus 7 times 10 minus 9 times 10 minus 4 times 10. Okay. And when you check this out, this does turn out to be approximately 13.41. Okay. So you can do it that way. Okay. So that's kind of slick. I know. It doesn't seem like there's some trigonometry there, but there we saw that we used trigonometry to prove this. So the rest of the homework you'll be doing, you're just computing a lot of areas of triangles. So have fun, and we'll see you next time.